Today we are going to address a third important category of elimination reactions. These elimination reactions proceed through an important mechanism which is known as E1cb mechanism. The mechanism is also known as a carbanion mechanism because a carbanion is formed during the course of a chemical reaction. We will check out later on how the carbanion is formed, but let's first focus on elimination reaction that proceed through three different mechanisms such as E1, E2 and E1cb mechanism. We have three different mechanisms such as E1, E2 and E1cb mechanism. Today we will focus on the third mechanism, that is E1cb. E1 stands for unimolecular and CB stands for a conjugate base. As conjugate base formed during the course of a chemical reaction, so that's why we call it a conjugate base unimolecular elimination reaction. Consider an example. Molecule which is known as beta hydroxyketone. As this carbon atom is alpha and this is beta, so that's why we call it a beta hydroxyketone. In a basic condition facilitated by hydroxide ion, which gives rise to formation of a new sort of compound which is known as an alpha beta unsaturated ketone. As a new double bond has formed between alpha and beta carbon atoms, and therefore we call it an alpha beta unsaturated ketone. This reaction proceeds through E1cb mechanism. Let's focus on the mechanism. Which is a two-step process. Step 1 involves here in the substrate we have two alpha proton which are acidic in character. These protons are acidic. When base is used, it abstracts the alpha proton for giving a carbanion which is a conjugate base of the starting material. So this is the first step, and this step is fast. As far as the carbanion is concerned, it is a resonance stabilized. Let me draw it again. This is an annulate. In the second step, the annulate rearrange for expelling the hydroxyl group. And we get a new sort of compound which is known as an alpha beta unsaturated ketone after expelling the hydroxyl group. So this is simple two-step mechanism. The second step is slow, which is known as a rate determining step. Here in rate determining step as only one molecule of a conjugate base or an annullate is involved, so therefore only one molecule determines the rate of a chemical reaction, so that's why we call it a unimolecular elimination reaction. As far as the conjugate base is concerned, it depends upon the base as well. If there is no base, so there will be no formation of a conjugate base or the carbanion. So indirectly the rate of reaction also depends upon the concentration of base as well, and in fact it has noted that the concentration of a base influence the rate of a chemical reaction. So generally we call it E1cb mechanism because it is unimolecular in character and a conjugate base is involved during the course of a chemical reaction, so we call it a unimolecular conjugate base elimination reaction. Usually E1cb mechanism is catalyzed by a strong base. Beside beta hydroxy ketone, in which the hydroxyl group acts as a leaving group, we can have different other compound as well that act as a good substrate for E1cb mechanism. For example, we can have a beta haloketone, we can have fluorobenzene, similarly we can have an alkyl halides, this is an alkyl halide. And another important category where E1cb mechanism operate. Usually for E1cb mechanism the beta position should have a group that could stabilize the carbon. For example, here at this position there should be a group that could stabilize the carbanion, or any such group that could stabilize the carbanion can facilitate the E1cb mechanism. For example, here in this case we get a carbanion like this in the presence of a base, and it is stabilized by the leaving group, which is halogen in this case. Here we have a proton that can be abstracted by a base, and we get a new intermediate which is known as benzene. As far as this compound is concerned, here this is a static proton and it can be taken by base, which can rearrange for expelling the bromine atom, and we get an alkyne like compound. As far as the mechanism is concerned, this is quite important and has important application in organic chemistry, especially most of the enone are made through E1cb mechanism. Compound of the form are known as enones. So these compounds are made through E1cb mechanism. For example, we have a starting material. Here we have acidic proton, much like a beta hydroxy ketone, that when reacted in the presence of a base, and we get the enone like a product. Both cis and trans isomers. So this is known as enone. So this is an application of E1cb mechanism. This is application number first. Second application is important with respect to a penicillin synthesis. Consider the structure of penicillin is usually this is a simple structure of penicillin. Here we have alkyl group. As far as the side chain is concerned, it can be incorporated with the application of E1cb mechanism. During total synthesis, consider an example. In which a phenoxyacetyl chloride, this is phenoxyacetyl chloride is treated with triethylamine and then reacted with amines, and we usually get an amide functionality. So this amide functionality here in penicillin structure can be introduced with the application of E1cb mechanism. Consider the mechanism for conversion of phenoxyacetyl chloride to an amide. Here we have two acidic protons. Let me show one of them. A base such as triethylamine, abstract it, and we get a resonance stabilized carbanion, which rearrange like this. And ultimately a chlorine group is expelled in the second step. And we get a species like this, which is known as ketene. And this ketene is an important intermediate during the course of conversion of phenoxyacetyl chloride to an amide. This ketene is electrophilic in character, and it reacts with amine in a nucleophilic attack. A proton exchange takes place. Here we have a double bond. Again, this structure rearranged like a proton is taken from an F or a protonated amine, and we get a desired amide. Let me clear it right over here. So this is an amide. Usually the side chain in penicillin is incorporated through E1cb mechanism. So this is second application of E1cb mechanism. The third important application is Robinson annulation. Consider the reaction. This is methyl vinyl ketone, and this is starting ketone. In the presence of a basic medium, we get a Michael addition. And we get a compound like this. Here we have acidic proton that can be taken by base, and we get an annulate or intramolecular aldol condensation. For getting a species like this is an annulate which take this carbon atom and it is protonated. So this is again a beta hydroxy ketone, like the earlier substrate we have used for E1cb mechanism. When it is treated in a basic condition, again we get a product known as an alpha beta unsaturated ketone, and this reaction is known as Robinson annulation or ring formation, in which a 6-member ring is formed. So again here an E1cb mechanism is involved during the conversion of the beta hydroxy cyclic ketone into an alpha beta unsaturated ketone. So this step is E1cb mechanism. And as far as the fourth application, again we have aldol condensation that we have studied on the first slide, especially with respect to conversion of a starting material into a product. Let's consider the first slide. So basically in aldol condensation, two aldehyde or ketone molecule, for example we take acetone, when it is treated with a base or acid, so an alpha proton is abstracted for giving a base which is resonance stabilized, and we get an annulate like this, what we have obtained in the first case. This annulate it to another molecule of aldehyde or ketone, in this fashion. protonation take place, and we get a beta hydroxy ketone in this fashion. So this is simple aldol condensation in which two aldehyde or ketone molecule condense in the presence of a base for give rise to formation of a beta hydroxy ketone in the first phase, and then the beta hydroxy ketone undergoes an E1cb mechanism in the presence of a strongly basic condition for giving an alpha beta unsaturated ketone. So let's revise the important point again. Usually elimination reaction proceeds through three different mechanisms such as E1 unimolecular elimination reaction, bimolecular elimination reaction, and unimolecular conjugate base elimination reaction. Here we have an example of E1cb mechanism in which a beta hydroxy ketone as a substrate undergoes a strongly basic condition for generating an alpha beta unsaturated ketone, and this reaction proceeds through an E1cb mechanism or unimolecular conjugate base mechanism. Basically the mechanism is a two-step process. The first step is first. This is first, in which a base abstracts a proton for giving a carbanion or conjugate base. This carbanion is resonance stabilized. Here we have shown a resonance stabilization of the carbanion. In the second step, this resonance stabilized structure rearranged for expelling the beta hydroxyl group, and ultimately we get an alpha beta unsaturated ketone. This step is slow and rate determining step, as a single molecule is involved, so that's why we call it a unimolecular elimination reaction. Here we have some example that could act as a good substrate for E1cb mechanism. We can have a beta haloketone, we can have a fluorobenzene, similarly we can have alkenyl halide. So these are three different examples which demonstrate E1cb mechanism reaction. Any group that can stabilize the carbanion can act as a good substrate, or the molecule where we have a group that can stabilize the conjugate base make the entire molecule a good substrate for E1cb mechanism. We have some applications of E1cb mechanism. First is the formation of enones, especially the type of this compound ketone in which we have a double bond are known as enones. So enones can be made through E1cb mechanism, especially as far as the beta hydroxy or the substrate is concerned. There should be a presence of a beta leaving group and an alpha acidic proton. Here these are acidic proton, both are acidic proton, which I have circled. The second application of E1cb mechanism has noted during the synthesis of penicillin. In which the side chain to a beta lactam ring can be incorporated through the application of E1cb mechanism by choosing the substrate of phenyl phenoxyacetyl chloride that is converted the structure into an amide functionality. Here I have given a mechanism. In which a base abstract the alpha proton of phenoxyacetyl chloride for giving a carbanion. It rearranges for ultimately give rise to formation of a ketene, which is an important reactive intermediate that acts as an electrophile. This electrophile is attacked by a nucleophile amines for giving a structure, and ultimately we get an amide functionality, and this is a side chain in the penicillin structure, which is linked to a beta lactam ring. This is a beta cyclic amides are known as lactam. So this side chain is incorporated into penicillin structure through the application of E1cb mechanism. The third example is Robinson annulation, in which this step involves E1cb mechanism, in which the cyclic beta hydroxy ketone are transformed into a cyclic alpha beta saturated ketone. And the fourth example is aldol condensation, in which two aldehyde or ketone molecule combine for making a beta hydroxy ketone, which are ultimately dehydrated to an alpha beta unsaturated ketone. Thank you for watching the video.